When we picture empty space, we usually imagine a perfect void, a silent black emptiness with absolutely nothing inside it at all. But modern physics tells us that what looks empty is often far from empty, and the truth is much stranger than it seems. From the largest structures in the cosmos down to the tiniest quantum scales, the idea of emptiness keeps breaking apart under closer inspection. For centuries, philosophers and scientists argued over whether a vacuum was truly nothing or whether space itself had hidden structure. In a laboratory, we can pump air out of a sealed chamber and create what looks like an almost perfectly empty vacuum. As the pressure drops lower and lower, fewer particles remain, and the chamber begins to resemble the emptiness we imagine in space. But even in these carefully controlled setups, a handful of particles still linger, reminding us that perfect emptiness is extremely hard to create. So even the cleanest vacuum we can build is not truly empty, and that is only the beginning of the story. Out in space near Earth, the darkness looks empty to our eyes, yet particles, radiation, and energetic activity are constantly passing through it. The sun releases solar wind, a continuous flow of charged particles that streams outward across the solar system in every direction. Those particles interact with magnetic fields, planets, and each other, turning apparently empty space into a dynamic and active environment. Even the vast regions between stars contain thin traces of gas, atoms, and dust drifting across what we casually call the void. These materials are spread incredibly thin, but they still matter, helping shape stars, nebulae, and the larger structure of galaxies. Then when we zoom into the atom, we discover that matter itself contains huge regions that seem empty at first glance. If an atom were enlarged to the size of a stadium, its nucleus would be tiny, while most of the interior would appear open. But quantum physics tells us that this apparent emptiness is not just blank nothingness because particles do not behave like tiny solid balls. At the quantum level, empty space becomes even stranger because the vacuum itself is alive with constant fluctuations and activity. According to quantum theory, brief particle pairs can emerge from the vacuum and vanish again almost immediately after appearing. So what seems like emptiness is more like a restless background, full of temporary events happening too quickly for us to notice directly. Physics also says that invisible fields extend throughout all of space, even when no obvious particles are present at a given moment. What we call particles may actually be tiny excitations or ripples in those deeper fields that fill the universe everywhere. One famous example is the Higgs field, which exists throughout space and helps give fundamental particles their mass. Gravity adds another layer, because space is not just a passive backdrop, but something that can bend, stretch, and curve. Around planets, stars, and black holes, spacetime itself is distorted, meaning even empty regions have shape and geometry. In fact, experiments suggest that a vacuum can produce real physical effects, even when it appears empty to observation. The Casimir effect is a famous example, where quantum fluctuations in a vacuum create a tiny force between metal plates. Even a region that looks dark and cold is never completely silent, completely still, or completely free of energy. Ancient radiation from the early universe still fills space today, surrounding everything as a faint cosmic background glow. Ghost-like particles called neutrinos also race through the cosmos, passing through planets, stars, and even our own bodies. And on even larger scales, unseen influences such as dark matter may shape galaxies through gravity despite remaining invisible. So when you reach into what looks like empty space, you are entering a realm filled with fields, energy, particles, and structure. What we casually call nothing may actually be an active stage where the deepest processes of the universe are always unfolding. That idea changes how we think about reality because emptiness turns out to be part of the universe, not the absence of it. Empty space is not just a gap between objects, but a physical ingredient in how matter, energy, and forces actually exist. From tiny quantum fluctuations to the structure of galaxies, the universe stays connected through this rich and active vacuum. So is empty space actually empty? The deeper science suggests that what looks like nothing is anything but nothing.